Hello. Infrastructure, we all know, is like backbone of all software development activities. In today's world, there are a lot of infrastructure changes that impact general software development cycle. In next 5 to 7 minutes, we will see how CLM can accommodate this change so that all software development activities are smooth. Agenda is going to be to look at a real world use case and then go through the steps that are involved in CLM and then a demo. We see a lot of infrastructure changes around adding physical servers, adding new switches, and then removing older switches which are no longer in use or physical servers that are outdated. Apart from that, other infrastructure changes would be related to consolidation of resources, resource management, etc. To accommodate changes we just discussed, CLM has few steps that needs to be performed. For these steps, there are a couple of prerequisites. We would need a REST client or a SDK kit that is provided by CLM. At high level, if one has to see, the steps involved would be offboarding of various resources, offboarding of services, that is service offering instances that these servers or switches are using, unmapping of tenants from network container, unmapping of compute pool from network container, the offboarding cluster related to the pod, and finally deleting the network container. And on the other hand, to make sure that these offboarded resources can be utilized even after offboarded, we would need to onboard them with the new resources that we are adding. We would see a live demo on how to achieve this. For the purpose of live demo, we have already created two pods. These two pods are serving different hardwares and different clusters. There is a infra cluster 1 and there is a infra cluster 2. On each of this pod, we have created a network container. They are called as cluster 1 NC and cluster 2 NC. If we traverse to resource tab, we can see that we have onboarded two clusters and both of them belonging to different pods. On each of these clusters, we have provision 1 SOI each. If you can see now on the screen, we have a cluster 1 request and then we also have a cluster 2 which is provisioned on the cluster 2 pod. From the database, we have picked up the instance ID of the SOI that we need to offboard. This is the instance ID that we need to offboard. We will use the REST client to offboard this SOI. This is the URL that would be required to offboard the SOI. Offboarding would take around 5 to 10 minutes depending on the size of the server. This is the SOI that is on top of cluster 2. Once this is offboarded, we would not see any SOIs here. As we can see on the screen now, the SOI is no longer available. Next steps would be to offboard the other remaining resources. We would go back to the admin console and start offboarding other resources. Before we offboard the network container and other resources, we have to make sure that the port group that is belonging to cluster 2 is also deleted from the VMware. We will now delete the port group from the VMware. The port group is deleted. We can now proceed to delete the network container. So now the network container is deleted. We would offboard other resources like cluster and the pod. Cluster is offboarded. Next we will offboard the pod. So we have successfully offboarded all the resources related to the cluster 2. Next step would be to add the switch, the new switch, or rather the switch that was being used for cluster 2 into cluster 1 and then resync the pod. To do this, we would be injecting the cluster into the pod, the cluster 1 pod from beginning. We have opened the pod in the pod view and selected a add node. These are the details that we have filled for the new switch that we need to add. We will go ahead and save this, which will add the new switch from cluster 2 onto the cluster 1 pod. So now we can see that newly added switch is available in pod belonging to cluster 1. On CLM UI from admin console, we would go ahead and do a pod resync, which will bring in the switches to the pod in CLM. We would select synchronize pod, and this operation will bring all newly added hardware. The pod resync operation was successful. Next step would be to import the container blueprint for cluster 2 switch and then onboarding other resources. After successfully onboarding container blueprint, we would onboard the cluster 2 for the pod. After onboarding cluster, we would create a new NC which would create a switch pod on cluster, the newly introduced cluster. While NC creation is in process, we can create the compute pool for this newly added switch along with the virtual disk repository. The network container we submitted has been created. The next step would be to map tenant and compute pool to this network container. Now we have successfully re-onboarded all the resources and the restructuring has been successfully completed. The last thing would be now to get back this old SOIs which were running on old cluster back onto the newly created network container. To achieve this, we would go to log into the quick start menu from workspace and select onboard existing virtual machine. We would select type as VMware, the tenant as cluster 2 tenant, the user as cluster 2 user, and the offering as cluster 2 offering. We select the newly created cluster here. We select the vCenter. From the list, we have selected the server we need to onboard. We do the add and we click on onboard. It will take a few minutes for onboard to complete. Once quick start successfully onboards, the user will be able to see the SOI on his console. With this, I'll end the demo. Thank you.